We're going to look at some absolute max and absolute min. So we want to find an absolute maximum and an absolute minimum without ever necessarily seeing a picture. This means the highest y value on the graph and the lowest y value on all the graph. So we're going to do this pretty similarly to how we found relative extrema. The first step is the same. We're going to find critical numbers of the function. Remember, to find critical numbers, you're going to take that first derivative and set it equal to 0. So set f prime of x equal to 0 and solve. That's how we're going to find our critical numbers. But instead of always having to make a sign chart like we did for relative extrema, we're going to compare the y values of the critical numbers to the y values of the endpoints, or look at the end behavior if we're not given endpoints. So the second step is going to vary. So ideally, we will not have to make a sign chart as long as we're given an interval of interest that we're on, a lower endpoint to an upper endpoint. So we're going to find the y values of the critical numbers that are on the interval of interest and compare it to the y values of the endpoints. We want to remember the highest y value is going to occur at the absolute maximum. And the lowest y value is going to occur at the absolute minimum. So we're going to look at a couple functions here. Our first function is x squared minus 4. We want to find the absolute extrema for it. So absolute max and absolute min. So we're going to do our two steps. We're going to take the derivative and set it equal to 0 so that we can find any critical numbers. So our derivative here, derivative x squared is just 2x. The derivative of negative 4 is 0. So our derivative is 2x. We're going to set that equal to 0. And we can just divide by 2 to solve for x. Or you might already know 2 times something has to equal 0. That something must be 0. So there's our critical number. And now we want to compare it to our endpoints. Well, the downside is we're not given an interval of interest. We're not told what interval we are on exactly. So instead of being able to just compare y values of our critical number to our endpoint, we need to actually make a sign chart and figure out what the end behavior is since we aren't given endpoints. So ideally, our second step, we do not have to make a sign chart unless we are missing one or more of our endpoints. So second step is usually no sign chart unless you are not given both endpoints. You should be on an interval. I should say find the absolute maximum on the interval from -5 to 10 or something like that. But here we're not given either endpoint. We're not given a lower endpoint or an upper endpoint. So if we're missing an endpoint, if missing an endpoint, or both in this case, we don't have an upper bound or a lower bound, that's when you have to make a sign chart. We're going to compare our critical number to our end behavior instead of our end points, since we're not given endpoints. So for this, we're going to make a sign chart. We're going to put 0 on it first. That's our critical number. It makes the derivative 0. And we're going to test the number before and after 0. So I could test -1 into the derivative always. So I'd have 2 times -1. That would be negative. And then if I plug in +1, I'd have 2 times +1, which would be positive. So this graph goes from decreasing to increasing. So our sketch that we could do would look like this. It's decreasing. We have our critical number at x is 0 there, and then it's increasing. So now we need to find our absolute max and our absolute min. Well, first of all, we know that this is going to be a relative min. Just based on the shape of the graph, we know that decreasing to increasing gives us a relative min. And now looking at the end behavior of the graph, is that relative min also going to be an absolute min? Yeah, it is, because the left endpoint is going up and the right endpoint is going up. So this is the absolute lowest point on the graph. So to write this as a point, I would write 0, comma, and then I'd have to plug into the original function to find the y value. So I'm looking at f of x here. I'd be doing 0 squared minus 4, which is just going to be minus 4. So there's that as a point. If it just asked for the absolute min value, that would mean just the y value. All you'd have to type in is -4. If you're asked for just the absolute min location, that means the x value. So just some review from algebra. Location is the x, value means y value, and as a point, you just write both. And then comparing the critical number to the end behavior for the absolute max, I'm looking at the end behavior and it's going up to the left and up to the right without bound, which means there's no absolute max point where it just stops. It seems like the higher the x value you plug in, the higher the y value that you're going to get out. It's going to continuously keep going up on both sides. So for absolute max point, there is none. So let's compare this to the same exact function, but let's put it on an interval now. Let's look at x squared minus 4, but let's be on the interval from -1 to 3 and see how that changes our process a little bit. So I'm going to work this like it's a brand new problem. If you're finding absolute max and absolute min, your first step is to find critical numbers. So you'd take the derivative, which we said was 2x. We'd set that equal to 0 and solve for a critical number. 2 times something is 0. That something must be 0. So it starts off the same whether you have endpoints or not. But your second step is different if you have endpoints. You do not have to make a sign chart. Here I have both endpoints, so I don't have to make a sign chart. Makes my life a little bit easier. I'm going to do the second step up here. I'm going to find the y values at the critical number and compare it to the y values at the end behavior, or the endpoints. So my second step is to say, hey, my lower bound is -1. My upper bound is 3, because I'm on the interval from -1 to 3. So I'm plugging in -1, I'm plugging in 3. And then I'm going to plug in any critical number that's on the interval of interest. So my only critical number for this one is x equals 0. And I do not have to plug it in if it's not on the interval that I'm interested in. Well, 0 is between -1 and 3, so I do have to test it. And I'm just going to compare their y values. So I'm going to plug in -1 squared minus 4 into the original function, see what the y value would be. I'd get 1 minus 4 is -3. And then I do 0 squared minus 4 is -4. And then 3 squared minus 4 would be 9 minus 4 is 5. So on this interval, I want to say what's the absolute max and what's the absolute min. So I'm just going to compare y values. Which one's the highest y value between -3, -4, and +5? It's going to be +5. So my absolute max point would be 3, 5. My absolute max value would be just saying 5, and my absolute max location would be 3, the x value. Absolute min between -3, -4, and 5, the minimum y value is going to be at -4. So as a point, I'd say it's 0, -4. And there we've solved this problem. So the difference between having endpoints and not is basically being able to zoom in on a graph. So if we sketch what this looks like, we have 3 points we could sketch. We have 0, -4, so I'll say that's right here. And then we had -1, -3, and then the point 3, 5. So just kind of a little sketch of what this could possibly look like. So all we did comparing example 1 to example 2, example 1 was looking at the entire graph. There was no interval of interest. We were looking at the entire graph and saying, is there an absolute lowest point? And there was at 0, -4, but there was no absolute highest point. This, in example 2, just gives us the ability to zoom in on the graph. We care about x squared minus 4, but we only care between -1 and 3. Which one's the lowest y value and which one's the highest y value? So we have both. When we're just looking on that interval, we're comparing our endpoints to any critical number in between and seeing which one's the highest and which one's the lowest y value. And this is important in real life because most of the time you're stuck on an interval that you're interested in. If you own a company and you're trying to maximize your profits, well, there's still a realistic interval you have to be on. Usually you can make between 0, that's the least amount of something you can make, to maybe you're sewing t-shirts or something like that, and you can make up to 25 a day, and you're trying to figure out, well, what's going to maximize my profit when I consider cost in there? So you look on the interval between 0 and 25, and that is most companies. They have an interval of interest. Hey, we can make up to 20,000 in a day, but what should we really do? Let's look between 0 and 20,000 and optimize, find our absolute max profit, or absolute min cost would be another one.